All right, thanks, Alan. So this afternoon, I want to run through some of the data sets held by the department in the hope that people would find some time to explore them and experiment them while we're all stuck at home. So let's kick off with our exploration geochemistry holdings. All data collected on exploration tenements in Queensland is required to be submitted to the state as a requirement of holding the tenure in Queensland. So all the data is stored in QDEX or its replacement, which is the open data portal, which I've put up here, which is in pilot mode at the moment, but is functional for company reports and geochemistry. So the holdings of geochemistry are complete in that all the data is stored in the company reports, but several large-scale projects of data extractions have been completed to transform the data into a database that can be queried and manipulated more easily. The last compilation was completed in 2016 and focused on open file reports. And there was some internal extraction and confidential data as well. So there is still a gap between the database and the company reports. And so in the future state, the data will be submitted directly into that database and we won't have to compile it, but it's not the state we're in at this point. So the Geochem database has 160 tables and libraries. It's some sort of a legacy product. It comes from the Explorer 3 database. I'm sure some of you are horrifically familiar with it and some of you have never seen it before, but it's very thorough and it's got full lab details and methods and batch details for all the samples are required before they can be put in the database. So it's complete. And it's now available on the GSQ Open Data Portal as one package instead of 4 different packages. It has 26 major sample types. There's a guide available to cover the complexity of the data set so you can understand what libraries are linked to what tables without having to use Explorer 3, which is a proprietary product now, so you have to purchase that. And there is 160 tables. The majority of them are stored in the 5 main tables, which are the stream sets, the rock chip and the drill holes and the downhole geochemistry soil, and that's 5. This is just an overview sort of the life cycle of the database and where we're at with it. So current holdings were reached in 2016. And but there is a gap of probably 20,000 reports which aren't in that database at the moment, but they are still available as company reports. And just the figure in the top corner shows that the life cycle of data collection throughout a project. So there's considerable amounts of data collected in the exploration phase, which is captured here in these databases. But once a project moves along to development and mining, there's a large quantity of data which is never reaches the public domain. So I'm just going to step through a couple of the data sets. Initially, the soils database has 1.4 million analyses, and there's still probably that many left in company reports. You can see that the analysis are very much focused on 10 major elements basically associated with base metals and gold and their traces, and then there's a bit of a tail of other elements where there's on the order of maybe 10 to 20,000 analyses that have been done for up to 30 elements, but that's where the data stops. Move on to the Catchment Geochemistry. There's 750,000 stream sediment samples in the database, and there's more of a focus on gold and gold tracer metals, and they're probably more concentrated up the east coast, whereas the soils are more concentrated in the Mount Isa area. So this figure here has the catchments from the NGSA with the stream sediment samples in there, just to give you an idea of the data distribution. So you can see it's very much focused into a few little catchments, whereas the NGSA covers the entire state. So, historically, there is excellent coverage of gold and base metals data over the state, but there's not much coverage for outside of those 10 elements. So I thought there's potential there for minerals, geochemical detection of deposits, even though areas have been thoroughly explored. So in effect, much of the state is a clean state. We're looking for things which haven't been analysed for, like lithium or rare earths. And in Queensland, there is significant identified potential for critical minerals in a variety of settings. And so today I'm going to focus in on the felsi to intermediate igneous related systems of Cape York. And there's certainly potential outside of this group as well. And there's also Mafic, cobalt and scandium deposits inside the survey area on Cape York. Sorry, I skipped a bit there. I'll get into it. Sorry. This is just a map of the identified critical mineral deposits from Roger Skero from GA, which shows the Mafic potential critical mineral deposits in the country, and then felsic igneous related mineral systems that might bear igneous critical mineral deposits on the right. We focus on the Kennedy Igneous Province, top right there, over the Cape York Peninsula. So the Cape York survey was another overbank sediments survey, which was targeted on the work from the NGSA. So the NGSA, which Phil talked about, covered the entire state and identified that there was significant anomalism in rare earths in Cape York, and the Queensland government processed and released that as an atlas, which I'll drop in the chat. So I'm going to spend some time going through the results of the Cape York survey, which was completed in 2015, and just to have a look at particularly minerals which weren't covered in the traditional geochemistry. So there's extensive mineralisation associated with the Kennedy Igneous Province on Cape York, including the Baal Gammon deposit, which is got indium, which is interesting. There's nickel laterites, which contain cobalt and scandium. There's also some lithium mineralisation identified on Cape York. Just a brief overview of the geology of Cape York. I run out of time if I go on about it in detail, but the basement rocks in the west are the Palaeozoic to Mesoproterozoic, Etheridge and Savannah provinces. And in the basement in the eastern part is the Palaeozoic Thompson and Hodgkinson and the Broken River province. They're overlain by a suite of Mesozoic basins. There's a long history of igneous activity which affects all of these provinces. Then it begins in the Proterozoic and carries through to the Holocene. There's a broad suite of mineralisation associated with, particularly with the Kennedy Igneous Association, but there's other mineralisation as well. There's the nickel laterites are associated with the development of the Thompson, the early part of their history, and the laterization of that. There's also some interesting tertiary cobalt, lithium, cerium, hot spring deposits we'll talk about later. But yeah, basically it's a twofold division, which is the Tasman line. The outcropping Palmerville fault there divides the Hodgkinson from the Cohen and Etheridge provinces here. So it's a really diverse environment for geology, and it's all been intruded multiple times by large amounts of igneous events. All that red stuff is igneous rocks. So there's tertiary basalts and carboniferous volcanic events and granites. It's a wonderful place for geology. So the elevated rare earths in Cape York is probably the reason why we initially fired up the survey to go have a closer look at this after the NGSA. And so we've highlighted the cerium association. It's got rubidium and fluorine. So we think it's, initially we're thinking it's associated with the igneous rocks in Cape York. And the Permian Kennedy Igneous Association was our target of investigation, I guess. So this is the results from the Cape York catchment survey. Results highlight some contributions from particular granites, but also significant recycling of these contributions. So in the southern part of the survey area, there's the association of elements indicates that the anomalism is associated with the magmatic rocks, whereas when you go north, there's indications, particularly europium content, that the rocks the anomalism is associated with recycled rare earth bearing sediments in the Helby beds. So these Helby beds were investigated after this initial reporting and by a report by the department, and they suggested that the grades were anomalous but sub-economic in the northern part of Cape York, but there's still potential for mineralisation associated with the magmatic rocks in the southern part, particularly the Lind, Alice River and Mitchell River catchments, whereas the Wenlock and Lockhart rivers seem to be sourcing heavy minerals from the Helby beds. Another one, I thought it was interesting to have a look at cobalt, because that seems to be one of the focuses of GSQ work for the state government in Queensland in terms of catchment geochemistry, and something that has actually been analysed for quite heavily over the history of in the exploration geochemistry database. So there's something like 700,000 analyses for cobalt. And it doesn't actually show up very well in catchment geochemistry. I just thought it was an interesting exercise. The cobalt is dominantly anomalous in the areas where you've got these tertiary plugs that come up. So you're probably really just seeing olivine. In the Cape York area, even though we know we've got cobalt associated with nickel and scandium mineralisation in the Greenvale province, we don't actually see that reflected in the catchment geochemistry, whereas in the soil geochemistry we see significant anomalism associated with those deposits and some of the tertiary basalts as well. So it's obviously catchment geochemistry is not pure to everything. I'll just step through lithium now. But there's some significant lithium anomalism in Cape York. It's patchy, it's not as obvious as the rare earth anomalism we saw. But there is an association with felsic igneous mineral systems, so we thought it would be worth investigating. And also in the geochemical database, there's zero analysis for lithium. So it's really completely clean slate in the search for these sort of minerals. So the correlation coefficient suggests an indium gallium association, which is probably indicative of a felsic igneous source for the lithium. And so just zoom into the Cape York survey. And so there's these sort of effects along the coastline, which I think probably more related to evaporation and transpiration, although there is some sort of low-level anomalism associated with these felsic igneous rocks. But there is no lithium deposits here in this star, so there's a nice big lump of lepidolite in my front yard that I collected from there, which isn't showing up there. So I think this sort of falls in the inconclusive basket. There's some evidence that you can detect lithium using these overbank sediments, but there's also some fairly significant environmental factors that need to be filtered out before you can really look at the data sets. I don't think looking at all the data has worked in this case. But an association between light ion lithophile elements such as sodium, potassium, rubidium, and fluorine suggests that there is a volatile rich magmatic system associated with these pegmatites in Cape York, which you can detect using this data. And there's also some known hot spring deposits associated with tertiary basalts in the southern part, which are around here, I think. And they're not really causing these extremely hot catchments, but you can detect them using this method. I just thought it'd flash up lithium and germanium as well, and indium as well. Germanium and indium, because they're two elements that keep popping up in these sort of critical element lists, but there's absolutely no analysis in the Geochem database. So, and there's some significant anomalism associated with germanium around the Georgetown district, and there is significant anomalism with indium in the Mariba district. So the indium has been known to be associated with zinc, with tin mineralisation around Mariba, but the germanium is not, is poorly understood, I guess. So there's questions to be answered from this data set. It's really, really powerful data set. It's 68 elements, 189 samples, and it's things to be explored in this part of the world. All right, thank you very much. I'll post all the data in the chat, and I'll pass on to Geochemistry.
Thanks so much, Dom. We do have a question before you run away. So Mike Whitbread has asked if you normalise the stream sediment geochem to catchment size. He also notes that it might be against scavenging by iron and manganese.
Yeah, we haven't normalised the catchment size, but I think you certainly do see that effect for some of the elements, particularly when you get further west into the arid environments. You start accumulating things where it's very hard to explain them without that sort of effect.
All right. I'm going to hand over. Oh, no, we've got another question. Are there archived company samples held by the survey? And if so, what is the potential to reanalyse archival samples for multi-element?
I don't think there is. Joe, is there?
No, that was, sorry, Peter Collett.
Yeah, I don't think we have any.
We have the archive samples for Cape York, but I think, the archive sample for the NGSA is kept by GA. So you have to contact GA to get those samples.
Yeah, but in terms of company stuff, I don't think we hold any of that sort of thing, which is unfortunate.
No, we have a lot of dual core,
yeah,
which is available to be analysed, but less of the surface samples.